All right, the next thing we got to talk about in chapter 11 is surface area, and we're going to focus on prisms and cylinders today. So that's what you should be able to do by the end of this lesson, is find the surface area of a prism and find the surface area of a cylinder. So if we start talking about prisms, remember prisms and cylinders are similar because they have two congruent parallel bases. So one is a polygon base and one has a circle base. You have lateral and base parts. Lateral are the outsides, bases are top and bottom. So a lateral face is all this stuff right here. This stuff, the stuff back here, and the stuff back here. So it doesn't include the two bases. Same thing with this. It's all the stuff that's not blue. Those are your lateral faces. Your bases are the blue part. You have lateral edges that are where the lateral faces meet. And then you have base edges, which is where parts of the base meet. So we have two things here, a right prism and an oblique prism. The lateral faces of a right prism are all rectangles, but an oblique prism has at least one that's non-rectangular, so it's some type of parallelogram for the most part. The altitude of a prism or cylinder is a perpendicular segment joining the planes of the bases, and we call that the height, and we will need the height for a lot of our calculations. And we're going to do two types of calculations today, surface area and lateral area. Surface area is lateral plus bases. The surface area is the total area of all the faces and curved surfaces of a three-dimensional figure, where the lateral area is just the sum of the areas of the lateral faces. So basically, no bases. So let's talk about right prisms first. The lateral area of a right prism with base perimeter P and height H is P times H. So basically, you find the perimeter of this base, and then you multiply it by how tall it is, and that gives you this face here, the face back here, and the face back there. The surface area is that lateral area that we just found plus these two bases. We have to take into account like the top and the bottom of this block of cheese for the surface area. And then a cube is special because you have a bunch of squares here. And in order to figure out the surface area of a cube, you just have to find the area of one of these things, so this s squared, and then you have 6 of them, so you got to multiply it by 6. So let's do a problem. Find the lateral area and the surface area of the right rectangular prism, round to the nearest tenth if necessary. So let's find lateral area first. We need to take the perimeter and multiply it by the height. And remember, this perimeter that we're finding is the base perimeter, so it's all the way around here. So our perimeter, since it's a rectangle, is 2 times length, which is 9, plus 2 times width, which is 7. And if we add up 18 and 14, we end up with 32. So our lateral area is 32 times the height of this, which is 14. And if you multiply 32 and 14, you end up with 448 feet squared. So there's one problem down. The next thing that they asked us for is the surface area. And remember, surface area is this lateral area that we just found, plus our two bases. So basically, we found the area of everything on the outside. Now we got to take this top and the bottom and add those in. So our lateral area we just found was 448 plus 2 times our bases. So we got to find our bases. And again, because they're rectangles, all we got to do is multiply base times height, or length times width. So 7 times 9 is 63. So we'll do 2 times 63. And if we add all this up, you end up with 126 plus 448 which is 574 feet squared. So the lateral area, just all the outsides, all this stuff, is 448 feet squared. But if we add the tops on, we get 574 feet squared. I'm going to leave some problems for you guys to try on your own once you get done with these notes, and this is one of those problems. We'll go over it tomorrow in class. So let's switch gears and talk about cylinders. The lateral surface of a cylinder is the curved surface that connects the two bases. The axis of a cylinder is the segment with endpoints at centers of the bases. The axis of a right cylinder is perpendicular to its bases. So a right cylinder has an axis that goes straight up and down that's perpendicular to these two bases here. Where an oblique cylinder is not perpendicular, but its altitude is the same length as the axis. So this right here is obviously not perpendicular to anything, but that is the height. So again, we have lateral surfaces, which is the outside, and we have bases, which is like the top and the bottom. So our formulas are basically the same. The lateral area is the outside stuff, and this outside stuff always forms a nice rectangle. One of the dimensions of your rectangle is how high the cylinder is, and then the other one is the distance around the cylinder. And because the distance around is a circle, we use the circumference formula, which is 2 pi times the radius. That's how long this is. So the lateral area is 2 pi r h, where the surface area has to include that, and then we got to add on the two bases. So the surface area formula is actually exactly the same. You take the lateral area, and then you add 2 times your bases. And because our bases are circles, it's pi r squared. So let's do a problem with those. Find the lateral area and the surface area of this right cylinder. Give your answers in terms of pi. So the first thing I notice is that they give me the diameter. I'm not going to need that, but instead I'm going to need the radius. So let's find that. Now let's find the lateral area. Remember that this is 2 pi r times h. We got to find the distance around and then multiply it by the height. So basically we're finding the perimeter again, because remember, circumference is perimeter for circles. So we have 2 pi times the radius times the height. If you multiply all these together, you get 160 pi. And inches squared will be our units. So that's the outside. That would be like this rectangle if we could lay that flat. The next thing we got to find is the surface area. So remember, that has to include the top and the bottom. So surface area is lateral area plus 2 of your bases. So we just found the lateral area. And then we got to multiply 2 times our base. And since our base is a circle, we can use pi r squared. We end up with 64 pi. So remember, we have 2 of these here, so you end up with 128 pi. Add that to 160, and we get 288. So if you don't include the bases, it's 160, but if you do include the bases, it's 288 pi. This next problem, I'm leaving to you. So composite figures are when we throw more than one figure on top of another one, and then we have to find the surface area of that. The thing that makes this difficult is because this is one shape. When we find the surface area, we're going to find the surface area of this part twice. So we have to subtract that out once. So I'm first going to look at this rectangular prism down here, this guy here. Just the guy on the bottom. And I'm going to find its surface area. So in order to do that, I got to remember my formulas. Surface area is the lateral area plus 2 times my bases. Remember, your lateral area is the distance around. So 2 times 4 plus 2 times 2. So I get 8 plus 4, or 12. And then I got to multiply that by the height. So my lateral area equals 12 times how tall it is, which is 3. So this lateral area, I'm going to come up here and plug in. And then my surface area is going to be this 36 centimeters squared plus 2 of the bases. And remember, since these bases are rectangles, it's just 4 times 2, or 8 centimeters squared. So we got 2 of those. So it'll be 16 plus 36. So we end up with 52 centimeters squared. Now that is just this guy here. We need to do the same thing over for this up here. So now that we found the area of the prism, we need to find the angle, the area of the triangular prism. So this is a little harder to visualize, but we have the bases of this guy, and they are triangles. So the front and the back triangle. So that makes this here what we're going to have to find our perimeter of. So leave this one alone. Let's find the lateral area of that triangular prism. So we need to find the distance from here to here, and then we have to multiply it by 2 this time. That's the height. So if this is 3 tall and this is 4 wide, we're going to do 2 times 3 plus 2 times 4, 6 plus 8, which gives us 12. And then multiply by the height of this triangle, which is 2. So the lateral area is 24. And now the base is a triangle, so we got to remember 1/2 base times height. So 1/2 of our base, which is 4, times our height, which is 3. This gives us 1/2 of 12, or 6. And remember, we have 2 of these bases. So when we plug it into the surface area formula, we have the surface area of this guy is the lateral area plus 2 times our bases, which is 6. So we end up with 24 plus 12, or 36. So that is the top triangle. Now remember, we counted this bottom part here twice. We counted it for the triangle and we counted it for the prism. We need to subtract that out. And that, since it's the same as this base down here, has an area of 8 centimeters squared. So when we're all said and done, we have 52 plus 36, and then we got to take out the 8 that we counted twice. So when we do this, 52 plus 36 minus 8, you end up with 80 centimeters squared. And that is the total surface area of that composite figure. As I'm sure you guessed, I'm leaving this one to you. Try your best to figure out what this surface area is. Last thing we've got to talk about is the effects of changing dimensions. The edge length of a cube is tripled. Describe the effect on the surface area. So remember, if we have a cube, the surface area is 6 times the side squared. So let's find the surface area of this. The side length is 8. We can do 64 times 6, which gives us 384 centimeters squared. This is the original surface area. Now we're saying that this is tripled. So instead of 8, the new one is 24. So let's plug it in the formula and see what happened. 24 squared and then multiply that by 6. We end up with 3,456 centimeters squared. So I want to relate these two things. So what I'm going to do is divide them and see what the relationship is. And I end up with the fact that this is 9 times bigger. So if you remember back to the last chapter, surface area is just area of a bunch of things added together. So just like the last chapter, if I change something, the area gets changed by that thing squared. So because I multiplied it by 3. 3 squared is the same thing as 9. So I'm leaving this problem for you to do. Hopefully you won't need to do all the work in order to tell me how the area is changed. I'm going to leave this problem to you as well, and we'll have time in class to talk about these and to go over them and maybe do them if you don't understand what's going on here. But you should be able to find surface area of prisms and cylinders. If you have questions, make sure you write them down and we can go over them together. Enjoy your night.